These are notes 7.6. We're going to solve these systems by using inverse matrices. We're going to start off with what is the identity matrix. If you remember back in Algebra 1, the identity for multiplication is if we take some number and multiply it by the identity, we're going to get that same number back. So for multiplication, the identity is 1. For addition, we have some number, we're adding something to it, we get that same number back. The additive identity is 0. So that's thinking back to Algebra 1 stuff that you've done. So what the identity matrices look like is this. Okay, so we've seen these before, right? Zeros on the diagonals with zeros elsewhere. Ones on the diagonals with zeros elsewhere. Those are called the identity matrices. So if I take a certain matrix, multiply it by the identity, I'm going to get the same matrix back. Okay, so I'm going to show that this is the identity with this. Okay, so I'm going to take this matrix and multiply it by this identity matrix, and I should get the same thing back. Let's see how it works. Okay, so remember multiplication, this is the 2 by 2, this is the 2 by 2. Inside numbers are the same, so we can multiply. Our answer will be a 2 by 2. Okay, take the first row and first column. 2 times 1, negative 2 times 1 is negative 2. 6 times 0 is 0. So we get negative 2. This one here, first row, second column, negative 2 times 0 is 0. 6 times 1 is 6. We get 6. First row, first column. Second row, first column. So 3 times 1 is 3. 5 times 0 is 0. Add them together, you get 3. And here, 3 times 0 is 0. 5 times 1 is 5, we get 5. So you can see that when I take this matrix, multiply it by its identity, we get the same matrix back. Okay, so now let's talk about the inverse. Okay, if you think back to Algebra 1, for addition, if I took some number and I added its matrix to it, its inverse to it, I would get the identity matrix back. So its inverse of addition would be 2 and negative 2 are inverses. Okay, for multiplication, I want to multiply and it would equal 1 things to equal 1. Same thing here in matrices. If I take a matrix, multiply it by its inverse, I'll get that identity matrix. Okay, now some things here to think about. Only square matrices will have inverses. And we'll only have an inverse if the determinant is not 0. Okay? So, how can I decide if these are inverses? Well, if these are inverses of each other, if I multiply them together, it should be the identity matrix, right? So if I multiply those together, let's multiply them. So, this would be 10 and negative 9 would be 1. This one here. 15 and negative 15, which is 0. Okay, here and here, be negative 6 and 6, which is 0. And here, be negative 9 plus 10, which is 1. So yes, they are inverses. Okay, so these are inverses of each other because when I multiply them together, it equals the identity matrix that we talked about up there. Okay? Okay, so how do we actually find the inverse matrix? Okay, so I'm going to show you two different ways. One is by using row transformations, and the other one is using the determinant. Okay, so first of all, row transformations. If I set it up like this, I have 2, 4, 1, negative 1, and then I make an augmented matrix with the inverse over here, the identity over here, okay? I want to do row transformations so that it looks like this at the end. I want to, on this side, I want to have the inverse, well, it would look like this, right? So I want this on this side and then numbers on this side, and the numbers over on this side then would be the inverse, okay? So, first thing, let's take this. Yeah, so let's just take this and let's multiply this 1/2. Okay, So if we take half of this row, it then makes it a 1 there, right? So that'll be, I'm going to write it over here, It'd be 1, 2, 1/2, and 0. You could do this different ways, but this is just one way. Okay. Need this to be a 0, so I'm going to do negative row 1 plus row 2. So negative 1 plus, I'm not changing, I'll do this first, I'm not changing the top there. So negative 1 plus 1 is 0. Negative 2 plus negative 1 is negative 3. Negative 1/2 plus 0 is negative 1/2. And negative 0 plus 1 is 1. Okay, so now let's get this into a 1 here. So I'm going to take negative 1/3 of R2. Okay, so negative 1/3 times 0 is still 0. Negative 1/3 times 3 is 1. Negative 1/3 times negative 1/2 is 1/6. And this times that was negative 1/3. Okay, now I need to get a 0 up here. So I'm going to take negative 2 times row 2, negative 2 times this, and add it to row 1. Okay, so I'm going to put that down here. So negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1/6 would be 2/6, which is 1/3. And I'm going to add that to the 1/2. And it gives me 5/6. Hold on, is that correct? No. Negative 2 times this, be negative 1/3 plus 1/2 would give me 1/6. Okay, and then negative 2 times this would be 2/3. 2/3 plus 0 would be 2/3. Okay, so now I can say that my inverse, the inverse of this equation up here, which that was A, I'm going to call it A inverse. A inverse is equal to 1/6, 2/3, 1/6, negative 1/3. That's the inverse. Okay, so another way to do it is using the determinant. Okay, so first of all, I have to find a determinant. Okay, if you remember, we saw that it's this way minus this way, right? So that times that is negative 2, and that times that is 4. Negative 2 minus 4 is negative 6. Okay, so what I have to do to find the inverse now is 1 over the determinant, so 1 over negative 6. And then I have to switch these two around. Okay, so the A and the D switch, those two switch. So the 2 comes down here and the negative 1 comes up here. And the B and the C, these two numbers will just become negative. So this is a negative 4 and this is a negative 1. I shouldn't say they become negative because if it's already negative, we turn to be positive. They switch signs, okay? Now, when you multiply that through, this times negative 1 is 1/6. This times this would be 4/6, which is 2/3. This times this is 1/6. This times this is negative 2/6, which is negative 1/3. Okay, notice, same thing as we got over here, right? That is how you can find the inverse. Okay, now, how do you use the inverse to solve a system? Okay, so this is how we're going to set this up. We're going to set up our matrix equation. So we have 2, negative 1, 3, and 1. Okay, so just our coefficients times our x and y matrix equals what it's equal to, negative 8, negative 2. And you can see how this works. Okay, so remember if we multiply these together here, this is row times column, right? So it'd be negative 2x minus 1y, 3x, 1y. right? Okay, so multiplication there. So that is our equation. So now to actually solve this, what we have here is matrix A times our other matrix equals matrix B. So in order to, just kind of solve an equation, right, like 2x equals 8, you would divide by 2, right? You do the inverse, you do the opposite operation. So the inverse of A is negative A, right? Not minus, but we're going to multiply by the inverse of A on both sides. We're going to multiply this side by A inverse, and we're going to multiply this side by A inverse. Okay, so A and A inverse cancel out. So I just have the equation x is equal to A inverse times B. Okay, so I have to find the inverse of this one, multiply it by this, and it'll give me what x and y are equal to. Okay, so let's see how that's done. So let's find A inverse first. Okay, so you can use either of these two methods. I think I would prefer this one. I think I'd find it a little bit easier, but whichever one you want. So the determinant would be 2. Well, I'll kind of write it here. The determinant is equal to 1 times 2 is 2 minus negative 3, which makes 5. So 1 over the determinant. Got to switch these two, 1 and the 2, and change the signs of these. So 1 and negative 3. Okay, multiply it through. I get 1/5, 1/5, negative 3/5, and 2/5. So that right there is my inverse. Okay, now I have to multiply it by this B. So when I multiply those together, okay, this is a 2 by 2, this is a 2 by 1. My answer is going to be a 2 by 1, right? Okay, so first row, first column. So that times that is negative 8/5. And that times that is negative 8/5. Okay, I didn't do my multiplication correct there, did I? Okay, so I take 1/5 times that is negative 8/5. 1/5 times negative 2 would be negative 2/5. Together is negative 10/5, which is negative 2. Okay, and then this one down here, this times negative 8 would be what, 24/5. And this times this would be negative 4/5, which putting them together, adding them would be 20/5, which is 4. Okay, so I just solved for this x matrix, right? This matrix right here. So I know that x is equal to negative 2, and my y is equal to 4. Okay? Now, I'm not going to ask you to solve these with inverse matrices on a 3 by 3, except if I tell you to do it with the calculator. Okay, so if it's a 3 by 3 matrix and I say use the inverse stuff, I want you to use Desmos, but I want you to write out the steps to it. Okay, so my equation, my matrices would be 2, 1, 3, 1, negative 2, 1, negative 3, 1, negative 2, times the x, y, z matrix equals 1, negative 3, and negative 4. Okay, so this is our A, our x equals our B matrix. So our x is going to equal, we have to take the inverse of A and multiply it by B. Okay, so I'm going to show you in Desmos how to do all that. All right, so you can see from that Desmos there, we got.
Okay, so to solve these using this, we're going to go down to the matrix calculator, desmos.com all the way at the bottom. Okay, we're going to put in matrix A. Matrix A was a 3 by 3 matrix. Okay, so there I have matrix A. Now to find the inverse of that matrix, I'm just going to hit this button right here. Okay, well, I have to put matrix A first and then the inverse. So there is the inverse, okay? And you can turn it to fractions there if you want to. So that's a real easy way how you find your inverse to make sure you get it, okay? Now, what I want to do is I want to take matrix A inverse, this matrix, and multiply it by B. So I got to make B matrix here. And the B matrix was 3 rows and 1 column, right? So what it was equal to was 1 and -3 and -4. Okay? So I want to take A inverse and I want to multiply that by B. You can see A inverse times B gives you the answer of x equals 4, y equals 2, and z equals -3.
All right, so you can see from that Desmos there, we got this matrix back when I multiplied A inverse times B, which tells me that my x is equal to 4, my y is equal to 2, and my z is equal to -3. Okay. Like I said before, I will not ask you. I might ask you to do the, show the work to a 2 by 2 matrix, but I won't ask you to do the work. You can use Desmos for a 3 by 3 matrix. Okay. So here's another 3 by 3. I want you to just try this by yourself. I will say to be careful here. Remember, this is 2x, 0 y's, and then 4 z's. Times the x, y, and z equals 14, 19, and -7. Okay. So once again, you can go to Desmos, and my x is going to equal A inverse times B. Okay, so go to Desmos and do that.
Okay, so once again, go to desmos.com, scroll down to the bottom for the matrix calculator. I'm going to create a new matrix, which is a 3 by 3 matrix. And it was 2, 0, 4, 3, 1, 5, -1, 1, and -2. Okay, we can create matrix B a while. Matrix B was a 3 by 1, and it was 14, 19, and -7. Okay, so we wanted to do A inverse times matrix B, and we get our X matrix, which is our X, our Y, and our Z, are 3, 0, and 2.
Okay, so from our matrix Desmos, we got x, y, and z. Okay, next one, fitting a curve. Okay, so we have these 4 points. Let's say these are those 4 points there. And there is an equation that would go through those 4 points that looks something like this. Okay, it's an x to the third equation, so we have an x to the third. So we have this right here. It has to go through these 4 points. So kind of very similar to what we did before when there were 3 points in a parabola. We're going to do the same thing here. So let's take these and plug them in here. So this is like your y, right? X and y. So we have -28 is equal to a times -2 to the third plus b times -2 squared plus c times -2 plus d, right? So that gives us actually the equation, -28. Well, let me put that 28 on the other side, just because that's how we usually see them, right? So it would be -8a, that square root is 4, so plus 4b minus 2c plus d equals -28. Okay, so that's one equation. Take the next point. My y is -10. The x is -1. So I get -1 to the third would be -1 times a would be -a. The squared is 1b. -c plus d would equals -10. Okay. -4, plug that in, and the 1. gives me 1a plus 1b plus 1c plus 1d equals negative 4. Last point. Okay, gives me 3 to the third is 27a, and 9b, 3c, plus d equals 2. Okay, so we haven't solved any 4x4 matrices or equations, but we can do this. Okay, very simply, very easily with these inverse matrices, right? So if I set this up, I have negative 8, 4, negative 2, 1, negative 1, 1, negative 1, 1, 1, 1, 1, 1, 27, 9, 3, and 1. Okay, times, I'm trying to find my A, B, C, and D, and that's equal to negative 28, negative 10, negative 4, and 2. Okay, so we got our A, X matrix equals our B matrix, and then we just have to solve for it. A inverse times B. So we're going to use Desmos to find that.
Okay, so we're here again. We're making a new matrix. It is a 4x4, so we got a lot of numbers put in here. Okay, negative 8, 4, negative 2, 1, negative 1, 1, negative 1, 1, 1, 1, 1, 1, and 27, 9, 3, 1. Okay, so that's matrix A. Our matrix B is what it's equal to. So negative 28, negative 10, negative 4, and 2. So to solve it, all we got to do is A inverse times D. Okay, so my X matrix comes up to be 1, negative 3, 2, and negative 4. Okay, so we're going to use that to make our equation then.
Okay, so we have our A, our B, our C, and our D. So if we think about our equation right here, all we got to do is put those back in for our equation. So our function is P of X is equal to our A, which is a 1, so it's X to the third, and B is negative 3, so negative 3x squared. Our C is a 2, so plus 2x, and our D is negative 4, so minus 4. So if you think about what we just did, this equation right here will be a cubic that will go through these 4 points. You can go to Desmos and graph it and make sure we're right.